Imagine you're driving a modern car with a speed of 100 kilometers per hour and suddenly a person from nowhere appears in front of your car. Within milliseconds, you apply the brake. The ABS system will prevent your wheels from locking. The dashboard will display all the warnings, and the airbags would be definitely ready for deployment in the back end. But have you ever wondered what software actually is running behind all of this critical system? It's not Java, it's not Python, it's not even C++ in many of the cases. It's embedded C. And if you have ever dreamed of working in automotive companies like Bosch, Continental, Aptiv, Volvo, Mercedes, or developing softwares that control real hardware, then embedded C is one of the most important skills you should have. Hi, I am Aditi, and in this video we are going to understand what embedded C actually is, how it differs from normal C programming, and why almost every automotive issues depends on it, and what career opportunities it can open for you all. Let's get started. Firstly, let's understand the word embedded. An embedded system is a computer designed to perform a specific task. Unlike your smartphones or laptops, which can run multiple applications on one device, an embedded system is built for one dedicated purpose. For example, engine control units, airbag controllers, washing machine controllers, smart watches, medical devices, traffic light signals. Inside all of these systems, software directly interacts with the hardware, and the language most commonly used to develop this software is embedded C. In simple words, embedded C is C programming used to develop softwares that run on microcontrollers and interact directly with the hardwares. Now still some beginners would ask, is embedded C a completely different language? Then no. Embedded C is built on standard C. The difference lies in how we are using it. The normal C programming, you mainly write softwares for computers. Input comes from keyboard or mouse. Output appears on the screen. For example, calculator application, banking application, or a student management system. But on the other hand, in embedded C, your softwares control the hardware. Input comes from the sensors and output directly goes to the motors, LEDs, displays, actuators, or communication networks. For example, reading vehicle speed, turning on cooling fan, activating airbag, controlling power windows, managing battery systems in electric vehicles. So the language is still C, but the environment is completely different. Now let's answer an important question. Why do companies still use embedded C? Why not Python or Java? There are 4 major reasons: speed, hardware access, low memory, and reliability. So reason number 1 is speed. Embedded C generates highly efficient machine codes. Critical automotive functions must execute in microseconds, like your airbag systems. Reason number 2, hardware access. Embedded C can directly access memory addresses and hardware registers. This is extremely important when controlling your peripherals. Reason number 3, low memory. Microcontrollers have limited RAM and flash memories. Embedded C works efficiently even with very small resources. Reason number 4, reliability. Automotive softwares must run continuously for years without failure. Embedded C provides predictable and reliable behavior. That's why it remains the backbone for automotive software development. Now let's see where embedded C is actually used in vehicles. Modern vehicles can contain more than hundreds of electronic control units. Each ECUs perform a dedicated functions. So let's see some of the ECUs in your car. Engine control module controls fuel injection and engine performance. Transmission control module controls gear shifting. ABS controller prevents wheel during braking. Airbag control unit detects collision and deploys airbags. Body control modules controls lights, wipers, doors and windows. Camera monitoring system processes camera data and driver visibility functions. Battery management systems monitors battery health in electric vehicles. Almost all of these systems rely heavily on embedded C softwares. When you press a button inside a vehicle, there is a high chances of embedded C code is running somewhere behind the scene. Now let's talk about the career. Many students think software development is only mobile application, web application development, but there is an entire industry built around embedded softwares. Some common roles include embedded software developers, embedded test engineers, AutoSAR developers, diagnostic, firmware engineers, functional safety, cybersecurity engineers. Companies hire embedded C engineers including Bosch, Continental, Aptiv, Volvo, Mercedes, Volkswagen, Tata Technologies and many more. With strong fundamentals in embedded C, you can build a career in not only automotives but in aerospace, medical devices, robotics, industrial automations, consumer electronics. In today's video, we learned what embedded C is, how it differs from standard C programming, why industries depend on it, where it is used inside automotive ECUs, and the career opportunities available in this field. In the upcoming next video, we'll understand how an embedded C program actually runs in the backend inside a microcontroller and explore the complete journey of source code to machine code. If you're serious about becoming an embedded software engineer, then this series will take you from beginners to industrial level concepts step by step. I'll see you in the next video.